Dear friends, I am starting a new topic which is of great interest in the context of prescriptive analytics, a journey in linear programming within brackets LP in short form, part 1. I am beginning today. Linear programming enables prescriptive decisions in the context of constraints. So it's a constrained optimization technique. Let's give a brief introduction. An economist faces the problem of making an optimum allocation of resources among competing projects. So resources are limited, and you will have to allocate the resources to competing projects subject to many constraints. And what is the optimum allocation of resources? A business planning manager has to decide how many units of each product be produced to maximize profit subject to constraints on production capacity and demand for these products. So we need a model that can help us find the best solution in the context of constraints that impact the problem and the solution part as well. Linear programming provides solutions to such problem, and the word programming here means planning. It's not computer programming, it means planning. So we deal with problems where there are constraints, and you can find out the optimum solution subject to the constraints. Why is it called linear programming? What is linear programming? The word optimum used is either maximizing or minimizing an objective function or goal. Organizations do have problems such as minimizing cost of production or maximizing the profit. The resources that are available are limited in quantities, and therefore they are called constraints. And the optimization will have to take place subject to the constraints the organization has. Linear programming implies that the variables in the objective function or goal and the constraints are raised to the power 1 only, meaning the constraints in the objective function must be linear in nature. Typical application, one example we'll see. An advertising company wants to maximize exposure of a client's product and has a choice of advertising in different media that include TV and digital platforms. Google Ads, Facebook, and YouTube, etc. are examples, and these media charge different advertising costs. The ad company has to achieve its objective of maximizing exposure. That's a goal, subject to the constraints of advertisement budget, minimum and maximum number of ads in the various media, etc. LP can help the company solve this problem. So you have a goal and you have constraints, and you have to find out the mix of the various channels of the advertising media, including the digital platforms, that will achieve the objective of maximum exposure, reaching the maximum number of people. And there are other typical applications of linear programming: product mix problem, media planning, transportation, transshipment problem, blending problem, scheduling of nurses and doctors to the patients in a hospital, capital budgeting. These are the typical application areas, and I thought I will call this as part one, having given a background of linear programming with its key elements. So let's meet in part two to proceed further in the journey, and we may have 3 or 4 parts. I do not know, it could even be 5 before we complete the conceptual framework of linear programming with application. Thank you very much. We will see you soon in another video.